All right, section 4.4, the natural log function. So in the previous couple of sections, we talked about the function e to the x. The natural log and the e to the x function undo each other, they're inverses. So for example, if you've got the function f of x equals e to the x, and I say plug in 6, so f of 6 equals e to the 6th, which is roughly, let's see, need a calculator for that. E to the 6th power is roughly 403.429. So then if I take what I have here and then do the natural log of 403.429, my hope is that I get back to 6. So natural log of 403.429, it's 6.0000 blah 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 until 5118. So you might be asking yourself, well, that's not exactly 6, and that's because what I typed into my calculator wasn't exactly 6 either. So let's see what happens if we instead do the natural log of e to the 6th. If I put that into my calculator, my hope is that I'll get straight up 6. And that is what I get. So the natural log and e, they cancel each other out. If I were you, I would pause this video right now and make sure that you can find on your calculator how to do e to the x and how to do the natural log function, because a lot of times that's kind of confusing on a calculator, and now is the perfect time to figure it out. But moving on, this part right here, this is really the important part to get from this first couple seconds in the section. And that is that e to the natural log of x, though the e and the natural log cancel out, and what's left is what was in the parentheses, x. And then on the right, the natural log of e to the x. So natural log of e to a power cancels to just the power for all x. That's true for all x. But notice on this side, this is just for x greater than 0. So let's keep that in mind for a second and see what happens. So simplify the following. Don't forget your exponent rules from 4.1. So I have e to the natural log of 12 plus x. This is sort of like what's going on the left side, which I know cancels down to just what's in the parentheses, which is 12 plus x. And then for part B, this looks more like what's on the right, the natural log of e to a power. So that's just going to cancel to what the power is, which is 5x squared minus 5. And then part C is a little more complicated because it's not just e to a natural log, there's a little bit more here. So I think we're going to have to use some rules to sort of get it into a format we can use. So just off the top of my head, some of the rules that I can think of are if you have, and actually let's not use x. If you have b to the 2nd power times b to the 3rd power, that's just b to the 2 plus 3 power. And then if you have like b to the 5th over b to the 2nd, oh wow, oopsie doops, b to the 2nd power, this is going to be b to the 5 minus 2 power. So actually I think this one will help us. So I have a base, in our case e, and then something minus another thing. So I'm basically using this rule, but I'm going backwards from what you would normally do. So if I go backwards, I think I have e to the natural log of 5 on the top, and then e to the negative, oh no, not negative, e to the 4 natural log of x on the bottom. So this helps me on the top pretty well. E in a natural log, that's going to go away to just what's in the parentheses, a 5. But on the bottom, it's a little bit more complicated because I have 4 natural log of x, so I can't immediately do anything with my 2 rules up at the top. So, but what I am thinking is this is 4 times natural log of x, And there's some rule, I think it's this one. So if you have b to the 5th raised to the 9th power, that's the same thing as b to the 5 times 9. So this is multiplication, what I have over on the left, e to the 4 natural log of x, just like what I have here. So using the rule backwards, I think that I could rewrite this as e to the natural log of x raised to the 4th power. And then, so 5 stays the same, but then e to the natural log of x is just x, so I've got x to the 4th. But one thing that I'm thinking of is I have 5 over x to the 4th. So x to the 4th is going to look something like, I don't know, something like that. But it's got an asymptote at x equals 0, but it's defined on the left side of the x-axis and on the right side. But whenever we use the natural log of x, natural log of x has a domain restriction. So this is probably on the original function was probably only defined for x greater than 0. So I think for this to be technically correct, we would need to write for x greater than 0. I'm not sure. I don't think MyMathLab will care about that, but I thought it was worth mentioning. Okay, let's pause here for questions.